ID, right, is going to automatically assign her another address that's available on the network. So if this subnet mask was 255.0.0.0, which is what you would expect a Class A network to be, then the first octet is going to identify the network. The last three are going to identify the host. So as long as the first octet matches, any of the other three can be anything from 0 to 254, and the host can communicate. They're on the same network. Now, if the subnet mask that's here changes all that. Because when you have a subnet mask, you're really looking at, where's that? And in the Network Plus, we'll, and we're going to do a more extensive review of this. But in the Network Plus, you'll understand this in a lot of depth. All you're looking at is binary, really. So what you have to think about when you look at an IP address is wherever there's a 1, that part of the IP address is part of the network identifier, the network ID. Any zeros in the subnet mask are the host identifier. So forget about the 4 here, because we're not going to get into more detailed subnetting. Let's say that, just imagine that was a 5. Just purely imagine that was a 5. The highest you can get in binary is 255. All ones is 255. If you're not familiar with how to count in binary, it may be helpful to watch the video that's posted on this Network Plus Google Drive called How to Count in Binary, because it's super easy. And we'll be going over that in class, but it's like a 5-minute video, and then you'll understand it. But the only thing that's really important here is that if, for the A+, is that if you see a 255, that means it's all ones. If you see a 0, that means it's all zeros on the subnet mask. So if an octet has 255 in it, then that means that that has to match in order for any hosts to communicate on that network. So that's why in 192.168.1. whatever, any of those hosts can communicate. If I change that 1 to a 2, now it's 192.168.2. whatever. All those hosts can communicate, but they can't communicate with the host in the 1. subnet. Does that make sense?
It's like radio channels.
Makes sense because they're clearly two different numbers, but
the radio channels you can communicate between.
So Adrian, right here, from the A+, you learn about Class A, Class B, Class C, and Class D multicasting, but we're going to stick with A, B, and C right now. So if you look at this and you say, well, this is a 10, so this is probably a Class A. Well, it's not, because the subnet mask is this, right? So if I look at...
Hello.
Hi.
How are you?
Good. What are you looking for?
Actually, I'm looking for you, but you're in the middle of class.
What can I do for you?
Well, I was gonna, I would your class just in, I was mentioning what introductory would, and then a couple of tools in here.
Okay.
But, I just want to see this one.
Sure. Yeah, pass.
There's no breakout.
Okay, yeah, you want to talk to Lorenzo. Okay, so it's not a Class A, though, because the subnet mask isn't what a Class A would be. If this was a Class A, which is what the 10 is, then the subnet mask would be 255.0.0.0. And then this is our network ID. And then these can be anything, and the host can still communicate. Once I've changed these 3 to 255s, now instantly, this is no longer true. Now all these 3 have to match for the network ID to remain the same. Now the host ID is only in the 4th octet. Does that make more sense? So let's say, for example, that instead I put a subnet mask of 255.255.0.0. Now which have to match? Now which of these two?
the first two.
The first 2. Now the first 2 have to match to be on the same network. and then the last two can be anything, and the hosts can communicate on that network. If I was to change one of the first two, even by one number, then now I'm on a different network. Make sense?
Yeah.
Okay. Was that you, Angel?
Came out wrong. I thought it was Friday night. But I think the question you were asking was, what would the IP address be?
Yeah, so go back to the original question. So if Eliana was to plug into one of the other ports on that switch, let's go back and look. This right here, this is on the HP. This is the gateway, right?
Right.
So our gateway is 10.5.28.1. Now, it's just not a coincidence that my IP address has 10.5.28 as the first three. If this was a Class A network, a true Class A, class full network, not classless network, then these three wouldn't be that.
Right, they would be 255.
No. If this was a true Class A network and this was 255.0.0.0,
Oh, okay.
then, and the gateway was at 10.5.28.1, we can be sure that what would be up here for me to be on the same network?
10.5.
10. Just 10. That's all we can be sure of. Why?
Okay.
Because only 255 was here and the rest were zeros.
Oh.
Now, if the subnet mask was 255.255.0.0 and my router was at 10.5.28.1, what would I be sure that I would have up here?
10.5.
10.5. And the other two could be anything. The 28 wouldn't have to match. But because here we're at 255, 255, 255, remember I told you just imagine that's a 255, not 0. Then the first three have to match to be on the same network. So the DHCP server that is on our router here at the gateway is automatically assigning addresses, right? So I plugged in the HP into the switch. So essentially the switch is just acting as more ports. As long as there are more address assignments available from the DHCP server, more address reservations available, then it's going to go ahead and assign those out. So Eliana is to plug her laptop into the switch there. I was just assigned this. What is it likely? What's a possible address that she is going to be assigned?
25.20.177.
Perfect. 10.5.28.177. Would that be on the same network?
Yes.
Yes. Has that already been assigned to someone else? We don't know. We'd have to ping that address and see if it's been assigned.
So that last number can be anything between 0 and 2224.
Right.
Okay.
Okay, so you understand that part. Okay, so now that's helpful on. So now we can take that back and we can look here and say, okay, what is our network arrangement? So we can see the gateway that's there. Now we understand a little better why I was assigned this address via DHCP. So remember, a switch is smart, and so a switch, we're having another RJ45 cable